Hello everyone, myself Himanshu Chourasiya. The title of my poster is Bridging Boundary, TTbar, Double Holography and the Reflected Entropy. So reflected entropy is basically a computable measure to address the total correlation for bipatric mixed state, which is defined as the von Neumann entropy of the canonically purified state obtained from this mixed state according to this equation. And the boundary conformal field theory is a CFT with a conformal boundary, and the holographic dual of this BCFT is given by the usual ADS3 geometry truncated by the codimension 1 brane, where we apply the Newman boundary condition. The bulk action is given according to this equation. And the metric of the ADS3 geometry is given by this equation, where sigma and y coordinates are related to the usual Poincare coordinate according to this equation. Now let's assume that the brane is situated at sigma is equal to sigma 0. So the brane metric X is basically the ADS2 metric with a conformal factor given by this. So these people, Chandrasekharan, proposed the island formula for the reflected entropy between the subsystem A and B in the asymptotic boundary, which is given by this equation, and the holographic dual of this island formula is proposed by these people, which is the effect existential surface formula given by this equation. So let me explain what is this figure is. So here A and B are the two subsystem at the asymptotic boundary of the display geometry, and the blue curve are the Ricci-Kanafi surfaces. For the entanglement entropy, the green shaded region is the entanglement wedge for the subsystem union B, and this green curve is the EWCS. So now let me explain what is the holographic TTbar with the boundary. So TTbar deformation of the TD 2D CFT in the flat space is defined according to this equation, where I is the Lorentzian action and the mu is the deformation parameter, and the TTbar is the TTbar deformation operator, which is basically defined in terms of the component of the stress tensor TAB, and the TTbar deform theory with the boundary may be realized by ensuring that the deform theory preserves G2 symmetry with a fixed point at the boundary, whose bulk dual is given by the tension length plane in the it is the bulk. Now the holographic dual of the TTbar deformed CFT is still given by the ADS3 geometry, but now the asymptotic boundary is pushed deeper into the bulk. Mm, and the introduction of the G2 quotient modify the bulk metric according to this equation. Again, assume that the UW brane is situated at constant angle sigma is equal to sigma 0. So the brane metric is still given by the ADS metric with a modified conformal factor. Now let's add some conformal matter on the UW brane and then solve the modified Newman boundary condition, which gives us the classical tension at T is equal to 1 upon L. Now, let me explain the reflected entropy computation in the 2D eternal black hole. So I will explain in detail in my poster how this eternal black hole arises from the usual ADS3 CFT2. But let's assume that there is a eternal black hole, and in this case we will compute the reflected entropy between the black hole interiors in the presence of the TTbar deformation. So first, to compute the reflected entropy, we need to identify the entanglement entropy phases. So we have the two entanglement entropy phases for this scenario, basically no island phase and the island phase, and the entanglement entropy for the no island phase is given by this equation, and then we compute the reflected entropy, which is given by this equation. And for the island phase, the entanglement entropy is basically sum of the length of this green geodesics, which is given by this equation. And since the entanglement wedge is disconnected for this island phase, so the reflected entropy for this phase is equal to 0. Now, in the presence of the TTbar deformation, the patch time for the entanglement entropy phases is given by this equation. And in this work, we also plotted the patch curve for this black hole interior subsystems. So here, initially before the page time, the no island phase is dominated, but after the page time, the island phase is dominated. In this work, we also computed the reflected entropy between the black hole interior and the bath subsystems and the different region for the bath subsystem, and we find a exact agreement between these results. We also computed the reflected entropy for the tissue and the adjacent subsystems at the zero temperature for this TT bar deform. It is the CFT2. Thank you.